A magnetic coupling is a coupling that transfers torque from one shaft, but using a magnetic field rather than a physical mechanical connection. Magnetic shaft couplings are most often used for liquid pumps and propeller systems. Since a static, physical barrier can be placed between the two shafts to separate the fluid from the motor operating in air, magnetic shaft couplings preclude the use of shaft seals, which eventually wear out and fail from the sliding of two surfaces against each another. Magnetic couplings are also used for ease of maintenance on systems that typically require precision alignment. When physical shaft couplings are used, since they allow a greater off-axis error between the motor and driven shaft. Applications: some diver propulsion vehicles and remotely operated underwater vehicles use magnetic coupling to transfer torque from the electric motor to the prop. Magnetic gearing is also being explored for use in utility-scale wind turbines as a means of enhancing reliability. The magnetic coupling has several advantages over a traditional stuffing box. Some aquarium pumps are magnetic drive pumps. They use magnetic coupling between the motor on the dry side of an aquarium wall and the impeller in the water on the other side of that aquarium wall, with two face-to-face magnetized discs, one driving magnet on the dry side, and another driven magnet on the wet side of the glass. There are two options for designing the magnetic pattern on each disc. One option balances the attractive section that transfers torque with magnetic repulsion near the axis to nearly cancel out axial load. The other option designs the magnetic pattern to maximize the torque, and uses a mechanical thrust bearing to resist the attraction between the magnetized discs. A magnetic stirrer is another example of magnetic coupling. Magnetic couplings are often synchronous. Output shaft speed equals input shaft speed, or 1:1. The first few gears in the gear train of an Omega Megasonic wristwatch have no teeth. Instead, magnetic north and south poles on neighboring gears act like the teeth in trough of neighboring spur gears, as each gear drives the next gear in the chain. Such magnetic gears, like spur gears, always have gear ratios as the ratios of small integers. More sophisticated magnetic gearing uses pole pieces to modulate the magnetic field. They can be designed to have gear ratios from 1.011 to 1000. See also electromagnetic clutch, magnetic particle clutch. References